So when we're talking about programming a job in Mastercam, right, we bring in the work piece that we're going to machine. So in this case, if I add a new group, because I got this option turned on for only display selected toolpaths. So if I click on a toolpath, it's going to display the whole toolpath. If I click on an empty group, it's going to hide all my toolpaths. And so in this case, right, programming this, it's just a sample part. But basically, here's this part we want to machine. I mean, nothing super complex, but as a 5-axis example, it's got some cool functionality, some cool features to put on it. And we've got it sitting on top of a 5-axis vise, and that's sitting on top of one of their rock lock bases. And so we know basically that we've got a model that we're going to machine, we've got some fixturing components, and we've got some toolpaths, right? So I've created some toolpaths to actually cut the part out. Turn off the stock models. And so, okay, great. Well, if I go and I verify this in Mastercam Verify, it all looks great. But this is not the code that I'm running, right? That's not the code that is actually going to run on the machine. So what does the code look like in Mastercam? So if I take these operations, actually, just grab everything. It's easier to deselect these guys. So if I take this code, or even just one toolpath, and I post it, so I go to G1, and I turn off NC file, and I turn on NCI with edit and override. Again, this is just one toolpath, but they're all going to look similar. 5-axis paths are going to look a little different, so I could show one of those as well, because it's a vector-based path. This is a plane-based toolpath. So we have a coordinate system, a tool plane in space, and this is the actual code. So NCI files post the data in a 2-line set. And the first line is the NCI G code, and the second line is a bunch of data. And the data is separated by space characters. So each piece of data, and this is going to be like a date time code, but each piece of data is separated by spaces, and all this data gets loaded automatically into a predefined variable. So there's predefined variables in the post processor that capture this data. Some data never gets read. So for example, this is our kinematic tree, also known as the axis combination, which is being fed to the post, which tells the post these are the different components that are present in this particular toolpath. So we got a machine base, a y-axis, an x-axis, an a-axis, a machine table, some stock, a z, a b, a c. In fact, because this is MP fan, it actually is a 6-axis machine. It actually has X, Y, Z, A, B, and C, which means you can program literally any toolpath. So MP fan is just the generic 4-axis post processor though. So if we try to post out all this data with MP fan, it's going to tell us, hey, you've got tool planes or you've got 5-axis toolpaths, and I don't know how to process that data because I'm not a 5-axis post. Going down, all of this is preparatory. All this data here basically loads values into variables until we get to the first tool change. So the 1001 code is the first tool change. So all this stuff loads values into variables as kind of preparing the post processor to start the first toolpath. This is the start of file. So the 1001 G code calls the start of file $PSOF$ in the post processor, and then you just get motion. So all of this is motion code. You can see we've got GOs, GO, GO, G1, G1, I should say G0, G1, here's a G2, here's a G1. So it's just line and arc or rapid, right? That's what all the data looks like. And then eventually you get down to the end, and this is a long tool path, so I get down to the end here. And in this case, Sometimes there will be the next operation, but because I only posted one operation, it's just a 1003. Well, this is all just generic. It's all just centerline code for the motion of our tool, and it doesn't really get turned into anything usable unless you have a post processor. And Vericut kind of came about in the 1980s because programmers make mistakes and post processors aren't perfect. And so, you can do your best job setting it up, but if there's an issue in the post or an issue in the program, so let's say that the toolpath goes and gouges into what's supposed to be our, critical aerospace part, maybe this is a rocket part, and it's op one, and there's going to be more processing done to it, and then they're going to make these into nozzles. I don't know, but at the end of the day, how do you know if the program is good? Well, that's the idea of Vericut. So with Vericut, you have to kind of go through and you program your part in Mastercam, and you use the backplot and verify tools in Mastercam to make sure that the program looks as good as you can get it, right? I mean, ideally it would be perfect, but again, we have to test the post. We have to test the actual G code, reading the actual G code, and that's what Vericut does for us. So Vericut is not a post processor. It is just a machine simulation module, but it's a really good machine simulation module. And so, let's do this. Let's go ahead and post this out. So I'm going to replace this guy, and we use a Haas UMC 750. I've got a couple different versions of this, but this one happens to be from CNC Software. So I'll say OK. And I'm going to save this. And we need a couple of things. So we need to go and make sure that we've got a level that's got stock on it. So in this case, my stock is pretty easy because it's just a rectangular block. Right now I do have tool paths turned on, so they're kind of interfering. There we go. But in general, you want to have a good setup for loading into Vericut. And that includes having your stock on a level. I don't know what else is on here. Let me go and let's move this off to the side. So I'm going to go to home and do screen statistics. Okay, one solid, 26 operations, 8 tools, but it tells me there's 22 entities on this level. I'm kind of a big fan of having my stock with one entity on one level, my part model with one entity on one level, and then my fixtures on another level. So what I'll do is I'm going to take this stock piece and let's move it to a new level. So I'm going to move it to level 10. So we got one entity on that. I don't know what else is on here. I don't care. Just as long as I've, there's other stuff that's invisible. For now, I don't care about that. I just want to kind of do some separation. So I'm going to take my my part model. Let's move it to say 12. And this is going to be what we call our design model, which is just the actual finished part that I want to, after I've removed all my metal to a given tolerance, this is what we want to end up with, right? So I'm going to move that to level 12, and then, yeah, you can actually see we had some surfaces or something else that were hanging out on that level, so I'm just going to turn that off, and that looks good. And then vise and riser, let me do screen statistics again. 7 solids. Okay, so this will work as is. I actually typically will go through the process of taking all of this stuff and Boolean adding it together. And I will also go through the process of defeaturing the model. And why would I do that? data.
Threads take a lot of info and
Yeah,
memory.
100%. All the extra stuff that's outside of just the skin of the actual solid, all of these features in the 5-axis vise, all of that, basically it's going to get meshed. So it's going to get turned into an STL. And so all of these little features, I mean, this is just for decoration, and yet in terms of data, it's going to take up a ton of data in my STL model. So the more simple that I can make this, the less or the more lightweight the model is going to be, and the faster it will load into Verify, the faster because basically when I'm doing collision checks, one of the things we do in Vericut is we're going to be checking every tool position. We're going to be checking all of the spindle of the machine, so not just the cutting tool, but the holder and the actual spindle nose and the sheet metal. We're going to be checking that for collisions against the vice jaws, the vice, the base, and the rest of the machine itself. So like the B-axis platter on a UMC 750, all that stuff gets checked. Now I will typically not include things that are not really going to be in danger in my work envelope. So like these movable jaw carriers, for example, this bar in the center, there's no reason to include that because there's stuff on the outside that I would hit before I hit this stuff. So I'm actually just going to move this. Let's go. Okay, so I'm going to move those out, and then I'm just going to make this, let's renumber it. I'll just make this 14. So just because it's useful to see, now depending on where you work, and I'm not going to mention the place that we've been looking at, just because I am going to put this on the internet. So I figure, we'll try to keep this as kind of generic as possible. I'll just take you through real quick what I would do to de-feature the fixtures. First thing I would do actually is I would copy these. I'm going to copy these back to 12,000 and say, original fixture models. I'm going to make level 12,000 my main level, turn everything else off, and I'm going to go into model prep and I'll do remove history. I don't know where the models come from. I don't know, or I don't know where they came from, and I don't know if there's any operations that are done on these solids. Every time you transform a solid or you merge a solid in from another file, that operation carries legacy data with it. So if I use remove history, I can actually take these models and I can clear out all of that legacy data, which is going to make my Mastercam file more lightweight. So I'm going to do that on these 4 models, and these are the originals. I'm also going to go to my vice and riser level, and I'm going to do the same thing. Remove history. Now, there's a lot of stuff on here that is extraneous. Like, I really don't need it. And in fact, it's going to make my model contain just a lot more data. So there's some tools I can use to get rid of features. We do have some internal features on some of these models that are going to be difficult to remove, but I've got a way around doing that as well. So first things first, I'm just going to move this to its own level, call this 15. Rock lock riser. and I'll turn everything else off. So I'll make 15 my main, I'll turn everything else off. So because I've done no history, I've taken the history out of this model, I can now go to modify feature, and instead of creating body, I can tell it I want to remove a feature. So if I double click, I can double click on some of these features, like these little scallop cuts, and I can remove them right out of the model. And I can do the same thing to like these counterbore holes. And there's no harm in leaving these. It just creates extra data for us. So which is the whole reason I'm removing them, because I want to make this as basically as lightweight as possible, which means I want as few facets as possible in the STL or the mesh data. So I'll remove these holes in the bottom, and I also copied these to a different layer, and I did that on purpose because I may want to see the original stuff, but in this case, I just want to get rid of it. So we'll
This
see.
seems much more powerful than remove holes, right? With the add history.
Yes.
Yeah.
Modify feature remove gives you some really cool options. However, you have to be careful because you really, for example, if I try to remove a feature, it looks like I've actually got some plugs that are sitting over the top of some screw holes, which is just the way they've built the model. And if I go and I just try to remove this little pocket, what I'm going to end up with is orphaned features that are hanging out inside there that I can't remove. So you do have to be a little bit careful. But what I'll do is I'll remove these outside features first. And then what I'm going to do is just take this top contour, the top line, and I'm going to extrude it, and then I'm going to Boolean add it to get rid of that stuff.
Right.
So I cleared that out. I could go and do the same thing with all these internal features, but eventually I'm going to run into features I just can't get rid of. So instead what I'll do, I'm going to go to wireframe, just curve one edge. There's only a few lines here, 8 lines, so connect these edges. And I'll do a solid extrude. What do we got here? Oh, I'm on single chain mode. I'm going to unselect, go to full chain mode, good. Grab my full chain. I'm going to flip the direction. And I'm going to look to make sure it goes deep enough. It does not, so let's make this 2 inches. Boom. That should be good. And now what I'll do is solids Boolean add. So I'm on Boolean add. That's my target body. I'm going to add my tool body, which is that block that I just extruded. And basically I said add those together. So in a real quick operation, rather than going, I could have gone through and tried to defeature as much as I could get, but in this case, Boolean adding it together is the easy way to get rid of all that crap. I've had other models, tombstones and stuff like that, where 5 or 10 minutes you can just click around, remove. You just have to do it in the right order. So I can show you some order stuff a little later. So now what I'm going to do, this, if we look in our solid tree, is still Booleans together. So if I do a select, you can see the body, and then I got a Boolean add operation right underneath it. So to clear that out, I'm going to do model prep, remove history. And now I just turn this thing into a dumb solid. So if I do a select, and I select that guy, here it is. You notice I've actually got a bunch of different copies of this guy.
Yeah.
So I'm going to do this. those originals. So we got some stuff hanging out in there somewhere. First of all, I don't need those guys. So I'm just going to go ahead and get rid of those. Now I'll turn on this original guy here, and I'll turn on my riser and my vise, and I'll go to my solids. Okay, there's that body. So we know that that's the actual V62 or V562 base. There's another one. So I know I've got in my levels, I've got my vise and riser level here, and then I've got the original one over here. So having two is okay. Let's see what else we got. Okay, one of the jaws, second jaw, one of the jaws, a second jaw, right? So I got a couple copies of it, which is fine because I know I've got the originals and I've got the ones I want to defeature as well. I would probably go and rename all this stuff so that it was easy to identify what is what. In this case, I'm just going to go look at my riser. My riser looks good. I don't need that wireframe anymore, so I can get rid of it. I'm going to go to my other vise and riser level. And I would definitely go through and remove all this crap off the side, all that stuff. I'm not going to do that right now because it's just going to be tedious, but I will do, remove some of these features. Because anything you can get rid of just makes your model more lightweight.
Which means faster processing times.
Which means faster processing times, absolutely. So sometimes you can't just double click, it won't recognize that as an actual feature, because in this case, this little cutout also intersects this chamfer. So I could go around and I could get rid of the chamfer. In this case, I don't care, I'm just gonna get rid of those little cutouts. I'm gonna go to these little side holes. Circles, cylinders are the enemy. And they're the enemy because there is no such thing as a cylinder or circle in an STL model. It's just a collection of triangles. And because it's just a collection of triangles, anything that's got a curved surface is going to take up a lot of data. A prismatic block is going to take up almost nothing, right? Just a very few triangles. But any of these fillet radiuses in here are going to take extra. So in some cases, I'd actually go through and get rid of the fillets. Yeah, I know they're there, but as far as, making the data lightweight, we want it to be as lightweight as possible. And this is a case where I can't remove the fillet first because I've got that intersecting hole. I've got to remove those intersecting holes first. Then I can remove the fillet. Then I can go and remove these little counterbore holes. And that's really enough. Like I could pull out more. Oh, looks like got those holes in the bottom.
Now, the teeth of those jaws, are they going to cause a lot of issues with all those small?
No, I mean, I could definitely go through and just remove these little guys here because they are cylindrical. Now, one of the cool things, Control plus Shift plus double click to select similar features. So if I do Control and Shift and I double click.
Oh, there it was. Yeah.
It's like it's trying to find them, but then it won't let me find them.
That's weird. I saw them highlight, but then they went.
And Control Shift plus click to do all similar faces. Oh, Control Shift click let me do it.
Yeah.
Not really. It saw some kind of issue with them. That's a shame. So, And the reason it failed is because they're intersecting this feature, and it thinks that this feature was put on after. So if I pull this feature out, Now, here's something that happens. If you remove a feature like that, you're stuck. So this is also why I keep another copy of the vice jaw. Now, for what we're doing, is it going to matter? No. I mean, the extra little bit of processing that this is going to take, I'm probably not too concerned about it. It would be nice if I could do modify feature, remove. Well, let me remove one of them. Nope. So this is one of those cases where you have to decide what's important, right? If it was really important and I really needed to remove it, I would probably remove these little chamfer edges, and I would probably take this face and extrude it through, Boolean add it, and then remove history to get rid of all these little scallops, because it's not just going to let me remove those little scallops. So as a quick example of that, let's certainly come over here. Oop, not that guy, this guy. Get this down to where it is one solid face. I can leave that chamfer in, that's not going to hurt anything. I'm going to save it. Save often when you're defeaturing a model, because you can get stuff screwed up pretty quick. If you don't, I'll do modify feature remove on here, and that should be good. So now what I'll do is wireframe curve on all edges, grab that face right there, and then I'll do a solids extrude and flip it. And distance, I can actually grab an auto cursor point to grab a distance right off the model, 4.95. And then I will solids Boolean these together. And it's a Boolean add, and just that quick, I can get rid of all those little scallops. And I can do the same thing over here, etc. In this case, that's probably good enough. So model prep, remove history on that guy. I'm going to do remove history actually on all of these guys, because I've done work to them. And believe it or not, even though I've removed the feature, that data is still kind of hanging out there in the background, adding extra weight to the model. So I'll remove that stuff. Now, I want to add these jaws to this vise, because if I can make this all into one model, it's going to be even more lightweight, because I'm not going to have, sets of faces sitting on top of each other. And so to do that, and sometimes if it doesn't let you do it, you can actually go and just back up and kind of remove one feature at a time. And you can kind of search for, well, what is the last feature that was put in? What was the last extrude operation that was done? And you can kind of remove them one at a time. So I've got some fillets in here. That's going to be a little extra weight. So I'll go ahead and remove those, and that's looking a little better. So I'll bring these guys back. And the chamfers too, I would probably remove as many as I could. And the reason for that is just the weight of the model, right? Every extra feature just creates more data. And in this case, I'm not going to worry about all the chamfers. I'm just going to do the ones on the bottom. And you can only remove features from one model at a time. So I can't just go and grab all the chamfers on both jaws. It's going to tell me that. It's going to bark at me and say, hey, you can only work on one model at a time. So we'll, oh, and this is where I got to be careful. Because you can see I had that chamfer and I removed this other chamfer, but it left that little kind of extra face on there. And I don't want to end up with a face that's kind of embedded into the model. And just for giggles. Okay, so I've removed what I want to remove. I'm going to save that. And now in order to get these to Boolean add together, I have to modify one of these. I can either extend the bottom of these jaws a hair so that they intersect this vise body, or I can take the rails on the top of this vise and I can modify those and bring them up a little bit, but I have to have some actual physical intersection, like at least a thou. So I'll hide the jaws. I'm going to go to push pull. I'm going to grab both tops here. I'm going to grab my little ruler, and then as I bring it up, you notice I get my little ruler and it tells me the physical distance in that little blue data entry field. And I say data entry field because you can actually just start typing. So it said 125.125, but I just hit the decimal point button and then just typed in 0.004. I'm going to hit enter, which will accept the value, and then I'll hit enter again, which will actually complete that op, and then I'll hit OK. And then I'll do E or Alt E again to unhide. I use hide a lot. And what we have now is these models that should be physically intersecting by at least 4 thou, depending on if there was a gap or not before. So I'll do a Boolean add. So solids Boolean. And then we'll add this jaw and this jaw. Oh, and I got a warning. Boolean process would result in a disjoint body. Okay, so I have to escape out of there. Let's try this again. And I'm going to do model prep, push pull, and let's do 0.05. Now let's do 0.04. Now I can definitely see they're physically intersected. Okay, so now solids Boolean, and now these are all one nice body. I would definitely go through, if I was doing this for real, you know, on an actual model that I was running, I would get rid of all this other crap just because it's not needed. And that could be as simple as doing something like this. I'm going to do model prep, remove history, modify feature. So rather than going around and literally defeaturing all the, and I could go and I could click all those little weird pockets, but it's probably way quicker to just do extrude and then Boolean add. So get rid of these chamfers. Okay, that looks good. And I can do wireframe, curve on all edges. And then I can do solids. Oh, sorry, solids extrude. It's another one of those where that can bite you. Yep. So model prep, modify feature, double click it, okay. I don't think there are any other features that intersect that edge, so we should be good. I'll save it. And wireframe, curve on all edges, and solids extrude. I want to extrude to that point, which is 1.6295. That looks good. Then I can do a Boolean, and I can add this one to this one, and I just wiped out everything. Now we're getting somewhere, right? So now I can say, okay, model prep, remove history, and last thing I'll do is modify feature, remove, and I'm just going to remove this little pocket. Boom. Now we're cooking with Crisco. All right. So I'm going to save that. One more remove history, and then I'm going to turn on my rock lock base. I'm going to take this guy and do a push pull. 1/4 inch is fine. I dragged it, extended out the base by 1/4 inch, and I'm going to do one last Boolean. That guy to this guy. And remove history, remove history. Last thing I'll probably do here, just because it's a preference of mine, is clear all colors. So these are the face colors on a solid, and that's going to clear it out to just be empty. Now what do I got? I've got one level, and let's go, where is it? Clear empty level selected. And I'm going to renumber this one to 14. And I'm going to save it. I have 3 levels now. I have my fixture level with one entity. I have my design model with one entity. And I have my stock solid with one entity. You don't have to do this. But if you do it, it's going to make your Vericut run much quicker. So I could have used all that. And some people do. And some people prefer this because they get the visual and they're like, no, I want it to show my actual 5th axis vise and my rock lock base, and I want to see all the holes. And hey, more power to them. I've just done this long enough to know the simple, as long as you have all the exterior surfaces, the simpler you can make it, the quicker the verification is going to be. So, because we're doing a video, I'll just go ahead and do it with the original, because why not? I've got everything I need for Vericut except for I need to make sure, depending on how my post works, in this case, we are using a UMC 750, so we're using dynamic G codes. We're going to use tool center point control for the 5-axis, and we're going to use dynamic work offset for the 3+2. That being the case, I need to make sure that any plane that I use has the same origin. Because with those dynamic codes, that origin point, even though the plane orientation changes, the location should not. Unless you're going to physically set another work offset on the machine, which you could do. You just want to be sure you're setting the work offset at the top. So with the machine at BC0 for UMC 750. So here I've got, multiple planes that come in. It's just I've reset all the origins to be 0. And if you notice, each of these planes has a work offset set to manual and set to 0. And this is going to guarantee that each one of these is going to post with G54. So that's G54, that's G54. All of these, no matter which plane it is, are all set to G54. I am going to right click in my planes list, and we're going to do delete all unused, just to kind of clean it up a little bit. Ooh. So I was wrong about one thing. Oh, because this guy's not used, because it was selected. Okay, so now I'm going to right click, delete all unused. Okay, it goes away, good. So all of these guys all have their work offset set to 0, and they all have the same origin, which is at the top of my block. So in the Vericut interface, we can select the models that we want to import into Vericut. In this case, I've got, my solid, my design, and my fixture. We can import origins, which are going to come from our planes dialog. So this is going to be the actual physical work offset point that you're going to dial in at the machine. In the case of UMC 750, to simplify things, I'm just using one, just a single work offset right at the top. Okay, so that's how this is going to look. And we can import our toolpaths. But really, we want to post-process these toolpaths for the actual simulation. And what I'll do here, just to help make it so this isn't going to take all night, I'm going to go in and do a new toolpath group. We're going to call this Finish Ops. And I'm going to change this to, I'll call this Finish Hole Threading, and then these guys, I'm going to call this Op 10 example. And I'll save it. And I'm also going to take a quick look. The other thing that it'll import is tools. So we want to make sure, for example, I've got this spot drill, this heavy duty jobber drill, and then this thread mill. And all three of those tools are down at the end, and they're all defined with no holder. So I would definitely go back in here to those last operations. And I'm reasonably sure if I expand all these guys, yeah, tool 4, tool 5, tool 6, you definitely want to include the holder. So if we go and we look at the tool, we can just see the tool. But if we go into the operation that uses the tool, we've got an actual holder defined. And then the tool projection as well, how much tools stick out. This is tool 1. I'm going to go in here and do operation selection so that I can select something that uses tool 2. Oh, looks like it's just this last one here, 23. Call it tool 2 assembly. I'm going to grab all those ops again and do an operation selection and grab tool number 3. So there's 7 ops that use tool 3 or tool 3. Okay, this is T3 assembly. Okay. So I've got my operations here. I'm going to select all my ops. I've got them separated as a separate NC file name. So the NC file name is op10-example NC. It's program number 0. So just for sake of realism, I'm going to go and change the program number. Let's just make this, I don't know, 1100. One last save. And now before I go in and I load this into Vericut, the last thing I have to do is I have to post-process the file. So I've got it set to my UMC 755 axis mill post. I'm going to select OK.
I see you have that little ladybug like debugger button. I don't recall seeing that on mine. Is that an extra add-on?
No, that is now a function. It used to be in the advanced configuration menu. They've actually added it to system configuration. So that is the post debugger. And it's a good option, but it doesn't work great for a 5-axis post because there's so much that is locked away. So if I go to File, Configuration, and we go to Post Dialog Defaults, Enable Post Debugger. So again, it works great for like 3 and 4-axis posts, but for 5-axis posting, like if here, I'll just take a simple op. This is a facing op only. I'll post it. I'm going to say ask, and I'm going to go debug. We're going to call op10 example face only, and I'm running it through the debugger. Horizontal, and I'm just going to play it. So it gives me my NC output. Now this happens to be, only a facing op, so it's a pretty simple operation. But if I try to go and look at where the output is coming from, depending on where I click in the setup, it does show me some of the entries that create this, but there's going to be a lot of stuff in here. This one's got some stuff that's unbinned, but there's a lot of stuff in here that's basically locked up. So if I go to, it's showing me the output. Maybe not the best example, but there's a ton of stuff that'll be in here. There it is. All of the really great mathematics is in this encrypted section. So you can see there's a ton of stuff where it's like there can be stuff your post is outputting that you just can't identify. Let's see. Oh, right over the top of where's my post window. Let's go Cascade, History, View, PST. There we go. Window, Tile Horizontal. So depending on what you're looking at, if a lot of stuff is actually unencrypted in the post, you can find it. In this case, there's some stuff in here where we can find the output in the post section, which is great. And you'll see it's actually anything with the arrow in front of it, that's the output line. So the output line was generated starting with PCIR, so P circle, but P circle in this case called PNC output, then P circ out, then PS cool, then PCAN1 cool, then PP low high, then P abs inc change. But if you look at this line, this is the first output parameter. So this line started in P circ out. Here's P circ out, and here's the X out parameter that caused this X value. Then what was added to the line? I have a Y value. So if I double click that, there's the Y out. Then I go to the next line. There was no Z because Z is modal. So Z out here didn't create any output. And P out and S out didn't create any output because they're modal as well. So the next thing that causes output is this P arc IJK, which happens to be this J parameter. So I out didn't cause anything. J out's the next one. And then there is no K because K is modal as well. So we have basically X, Y, I, Oh, I out did cause something. There's the I out, and then there's the J out. But that's it. So we had an X, a Y, an I, and a J, even though there was a whole bunch of other potential output, modality prevented it from outputting. All right, so go ahead and close out that guy. And if we look in our Mastercam training, we have this 5-axis morph. We have the op10 example NC. Oh, we actually got an error file. Wonder what kind of error we got. There it is. So basically there was no real error. It was just telling us, hey, we were debugging and there happened to be an encrypted part of the post.
Okay.
So post processor execution initiated, unencrypted input file was this post file. Encrypted input file was this PSB file. Loading input files was successful. We initialized all the predefined post variables, strings, and post blocks. We did a search for everything, it found it, and then successful completion of the post processor execution. So no harm, no foul. Everything is good. I am going to get rid of those guys. So in the old days, before we could just pick models and have it automatically generate the design, the stock, and the fixture for us, we would actually have to save those as STLs and then load them into the interface. We don't really have to do that anymore. So I've got tools that are defined. So they've got their correct stick out and they've got the correct tool definition and the correct holder definition. We've got an NC file, which is the actual G code that we're going to run, which has been post-processed with the actual post processor we want to run. And we've got our models all on the kind of correct layers that we're going to use. I'm actually going to output this with the original fixture models first, just because it is kind of fun to see. So I'm going to save that. So what I did was I created a ribbon called Vericut, and the command is actually run Vericut. So to add it, if you don't already have it, if I go to like my home tab, for example, and I right click here and I say customize the ribbon, I'm going to go down to all commands. I'm going to scroll down till I find R for run Vericut. There's my run Vericut command, and that gets added when we basically do the installation of Vericut. You can tell it, hey, I want to install the MCAMV interface for whatever versions of Mastercam I've got. And so what I'll do is I'll do a new tab. And I'm going to right click and rename it. Call it MCAMV. I'm going to take my run Vericut command and I'm going to add it to that custom tab. And I'm going to take MCAMV, which is going to come right after my home tab, which is fine. And now we'll say OK. And there's MCAMV, and I just get one button that says run Vericut. So let's do it. This is launching the Mastercam to Varicut interface. I can now choose settings for a particular operation. So in this case, it is my op1. That's my program that I want. Now it's going to tell me what is my working directory. Working directory is generally where all of your Vericut files are going to go. In this case, if I just choose C-test MCAM training, it's going to go right into, it's basically it's going to dump everything in there. And that may be okay, it may not be. depending on where you're working, sometimes we actually want to go take, this is our working Mastercam folder. Maybe I want to make a new folder and call this, Vericut for, Op10 or for whatever program that I'm using. So I'm going to make that my working directory. My file name, that's the actual file name that I've got loaded in Mastercam. And right now it's going to use a project template, which is initialization.vc project or init.vc project. Typically, if you're working somewhere that's pretty well set up, you're going to have multiple project templates, and that project template is going to be based on the machine that you're going to load this onto. So maybe you're loading this into UMC 750, maybe you're loading it into an Akuma, maybe you're loading it into a Mazak or a Micron or a DMG Mori, or name a 5-axis machine, right? And so in those cases, you could click, open, and you could grab a different project template. Basically, we're just using init.vc project. Then you have a setup template. So setup template, same type of thing. If there are special setups, or maybe you have multiple setups. Maybe you're going to do an op10 and then you're going to flip the part over and do an op20 and then you're going to do an op30. You can have that set up. So all operations will be transferred. I don't want to transfer these ops because I actually have G code that I want to run. So I'm not going to select those. I'm going to go to models. Let's do our stock first. So you notice I can clear stock model, I can open an STL, or I can pick a piece of stock. So I'm going to go to pick a piece of stock. I'm going to grab that one and then hit escape. That loads it right in. I'm going to pick a part model. So I'll go pick a part. I'm actually going to go to levels, turn off the stock level so that I can pick my actual part. And then I'll do escape. And now I'm going to do my fixtures. And that's where I'm going to pick those guys and do escape. So those load all under the escapes. Model CSys, stock CSys. If I have a specific coordinate system that I want to attach these to, I can. In this case, I'm actually going to grab top for both of these. So top, an attached component is essentially just going to be attached. G-code tables would be if I was doing work offsets. I can load work offset data. I can do a bunch of things. In this case, I just want to use from and to. So I can't do that till I actually load, because init.vc project doesn't have a lot of stuff that's already pre-built. So I'm just going to let it run. Last thing I want to do is run my G code. So with my G code, get my op10 example, say open, there's my code there, and I don't really want to transfer for all those ops. I just want to run my NC program. I guess I don't have to worry about it because NCI is not selected. I'm just going to leave it set to op1. I can output the files, I can output and run, or I can just run Vericut. Run Vericut is only going to launch Vericut. Output files is only going to output the files I need. What I want is output and run.